In this example, I will show you another problem on how to build functions. Um, this is like the example one that we did before, but it's a different type of graph or different type of function that you are going to see. Okay, we'll start the problem. So if even if this information was not given to you, with whatever is given there, like a rectangle has one corner in quadrant 1 on the graph of y equals 16 minus x squared, another at the origin, a third on the positive y-axis, and the fourth on the positive x-axis, I am able to draw this graph. So let me explain. So the first one, it's telling the function is given to me as 16 minus x squared. So when I see this, I know that it's a quadratic function with a reflection with respect to the x-axis, and there is a vertical shift of 16 units up. So I kind of graphed it, and I'm calling this as the 16 point. It's a little off scale, so please ignore. And the first thing it's saying is you have a corner for one point is on this graph, and that point is this particular point here. One point is on the graph. Another point is on the origin, which is here. And the third is on the positive y-axis. So positive y-axis is this point. And the fourth is on the positive x-axis. How do I decide where to put it? Because it's saying it's a rectangle, and I know rectangle opposite sides are parallel. So by drawing that, I made a rectangle on the first quadrant. Now, let me come back to the graph. We all know the distance from here to here can be called as the width of the rectangle. And because this point is x comma y, I can say that length is x. And if that length is x, the top length is also will be x. Now the vertical distance would be y, which would be y here too. Okay. Okay, coming back to the problem, the question is asking me to write the area of a rectangle, again, as a function of x. So this is something you have to keep in mind, which means they do not want two variables on the right-hand side, just a single variable. We all know the formula to find the area of the rectangle is length times width. So here, if you call y as the length and x as the width, I can say area is x times y or y times x. Now, the same thing as we did before. If you look at here, I'm having two variables x and y, so I'm supposed to replace the y. And because the point is on this graph, I can replace this y with 16 minus x squared. And by doing so, I am ending up with a single variable equation, or a equation with respect to x as my independent variable. And you can simplify it if you want, foiling it out, and I think you can do that. Okay, and that will be the answer for A. Okay, coming back to B, it's asking what is the domain of this function. Now, one of the thing, because this is a graphical function and it's a word problem, now can I say that for this rectangle to be present, my length should be greater than 0 and width also should be greater than 0. If I don't have the length and width greater than 0, then I don't have a rectangle. Okay, so length is given to me as 16 minus x squared. So that could be greater than 0. So I'm calling the vertical distance length and the horizontal one width. So my length is x should be greater than 0. So the first x is greater than 0. So if I think of my number line, let me put a graphical view for you to write the domain. So if you think of your number line, your x is greater than 0. Therefore, if this is 0, it cannot be 0, everything to the right. Right? Okay, the first inequality, 16 minus x squared greater than 0, when simplified can be written as, if I simplify this means negative x squared is greater than negative 16, or x squared is less than 16, or x is less than 4. Again, we don't want the negative sign here. Okay, we don't want the negative 4. Okay, so x is less than 4. So if this is 0, 1, 2, 3, 4. So that is 4. X has to be less than 4. So for you to have a rectangle, your x value should be between 0 and 4. You cannot have 0, you cannot have 4, because when you have 4, 4 squared is 16, 16 minus 16 is 0. Okay, so your value of x should be 0 to 4, and that is the domain of this function. Therefore, the domain of this function is parentheses 0, comma 4. I hope you understood it. Okay, see, I graphed this function for you. There is one more information we have to do in this problem, which is the last step. So I'm going to move up the screen a little bit. Okay, it's asking for what value of x is the area the largest. So technically, you need to find what this distance is for the area to be largest. So for this, what you can do, you can use your calculator. Just in your calculator, plug in y1 equals x times 16 minus x squared. Hit graph. Now keep your windows x minimum 0, y minimum 0, x maximum, I kept it 10 in this case. We'll try and see. And y max, keep it 50. And if you graph this graph in your calculator, you must be seeing a upside down parabola like this. Okay. Now again, my x is along the x-axis. X in this case is the width. And my y is along the along the y-axis is my area. So anything that I get on the y value is the area for this problem, a of x. So the question is asking for what value of x is the area the largest. So I know the area is largest because that's the highest point. So if you can find that corresponding x value, that will be the answer for this problem. Again, what you can do is use your calculator, use second calc, then use the maximum option that you see, left bound, you find the left arrow, or just move your cursor to the left side of the point that you would look. Then go right bound, move it to the right side. Then when you come to guess, you would just hit enter again, and you must be seeing an x value. And whatever the x value you get, just write it up here. That would be the answer for this problem.